Now we're going to take a look at a more complicated problem. And what we're going to see here is that we've got underneath the square root a quadratic. And I'm going to square this, and the square root cancel. But as I do it to the left side, I want to do it to the right side also, and square that. Now again, like the last problem I showed you, this does not equal x squared minus 1 squared. Okay? What that should be is x minus 1 times x minus 1. On the left-hand side, we get rid of the square root, and we get x squared minus 4x plus 9. On the right-hand side, if I use my little trick that I showed you before, I should multiply the first two numbers. That should give me x squared. If I multiply x times negative 1, it should be negative 1x, and then I double that to get negative 2x. So again, I got negative 1x, and then I doubled it, and that's how you get that middle number. And finally, I take negative 1 times negative 1, and that gives me positive 1. So that was multiplying the last two. Again, you could FOIL, do the whole FOIL process, but this is like the short, cheating way of doing it. And then I should take my x squared and subtract it, because now I want to get all the variables on one side, or everything on one side, and get the numbers on the other side. Sorry, x squareds. And then those cancel, and then I'm left with my 4x's, my 4x and my negative 2x. So let's go ahead and add the 4x. And that causes the left side to cancel out, to be just left with 9. Let's bring that down so it doesn't become too much of a mess. And then the negative 2x and positive 4x should give me 2x, and then positive 1. So to go further, I should subtract 1, and I should end up with 2x equals 8. So to finish, I just need to divide both sides by 2, and I should get x equals 4. Okay? Now I should check for extraneous solutions again, but this time I didn't get two answers, so it's very likely that this answer will work, but I should still try it anyway. So let's go ahead and try that. I'm going to erase and make some room. So when I plug it in, I should get 4 squared is 16, minus 4 times 4 is 16, plus 9, and that's all underneath the square root. So really it's just square root of 9, and that should be equal to 4 minus 1. Again, without the square, because the original problem didn't have that. So it does work out. I get 3 equals 3. So this one checks out just fine. Okay. Now let's try one more problem. On this problem, we'll see that we've got bigger roots. So I've got a cube root. It could be a 4th root or a 5th root. All it means and all it changes is you just look at the number on the outside and you ask yourself, well, what power would I have to raise a cube root to get rid of it? So I raise it to, instead of the 2nd power, this time I raise it to the 3rd power. And if you do it to the left side, do it to the right side. Again, if it was a 4, you would raise it to the 4th. If it was a 5th root, you'd raise it to the 5th power. But because it's the 3rd, raise it to the 3rd, and it cancels, and I'm just left with z plus 5 equals 2z minus 6. Okay. Now, I just solve for z by subtracting z here. And I can go ahead and add my 6 also at the same step, and I get 1z equals 11. And that's my answer. I should check it. 11 plus 5 should give me 16. Square root of 16 equals, or sorry, cube root of 16 equals the cube root of 2 times 11, which would be 22, minus 6, which should give you 16. So the cube root of 16 should be equal to the cube root of 16. So this one does work. That is your answer. Okay. So that's how you solve for radicals, or equations with roots in them. Sometimes it's square roots, sometimes it's bigger roots.